In today's video, we're going to be solving rational equations just from purely seeing equations that are going to look something like this with no graphing utility available, just straight up solving with Algebra 1 and Algebra 2 skills. So here are some of the situations you're going to be dealing with. There will be common denominators. You will be making use of the distributive property, the zero product property, that is the ZPP, and then skills involving factoring. It might be the quadratic formula, it might be traditional factoring, but once again, we are going to be solving equations that are rational, so there will be variables in the denominator, and we will be focusing on skills that mainly involve finding common denominators. And well, let's just go ahead and jump into the first question. So take a moment to just pause the video, set up this equation, and then hit resume when you are ready, and I will go over the steps that you need to follow in order to solve this equation. All right, here we go. So you're going to begin with step 1. You need to factor your denominators so that you can determine the overall common denominator that you're going to need in this problem. You'll notice on the left-hand side, x minus 5, that's already factored. There's nothing more you can do there. But the x squared minus 3x minus 10 can most certainly be factored into a x minus 5 and an x plus 2. And what that allows us to now determine is that our common denominator is x minus 5 times x plus 2. Basically, your common denominator, this would be something to really focus in on right now and perhaps just write down as its own little note. The common denominator is always going to be all of the unique denominators that you see in the entire equation. Unique. So you will notice there is a copy of x minus 5. We only want one x minus 5 in our common denominator. And then there is only one x plus 2, so we would want our common denominator to also involve x plus 2. Just adding this on the fly, just to further this point, let's just say there was a front piece to this that said an x minus 7 was in that denominator. Well, that is another unique denominator, so we would have to include that in the overall common denominator, which would be quite a lot of work to do, having 3 binomials multiply together for one common denominator. That would be quite a lot of work and probably more than you would be doing in this video. But just to, again, really highlight the main point of this concept, you need to find a common denominator. And that common denominator is always going to be made up of the unique denominators that you see in the equation after you do a little bit of factoring so that you know what those binomials are. Hopefully that made sense, and if not, well, perhaps the visuals are going to help take care of things. So let's just go ahead and proceed on to step 2. We will now be multiplying both sides of this equation by the common denominator that we have now established. So that's going to look something like this. Take x minus 5 times x plus 2 and put that multiplying both sides. Technically, these binomials have 1s in the denominator, and now that we have the same thing in the numerators and denominators, these binomials, we can go ahead and start canceling things out. Remembering that x minus 5 times x plus 2 was the result of factoring that denominator. That's what you saw the animation do really quickly. Just remembering that it is a product of x minus 5 and x plus 2. You're allowed to cancel out that entire denominator right over here on the left. That's entirely gone, just leaving you with x minus 6. And on the left-hand side, we have the x minus 5s that you would cancel out, and then just the x plus 2 is what is left over. Very important step. This is the whole point of having the common denominator being multiplied on both sides. You are allowed to cancel out the denominators that match up, and then anything that is left over is just going to stay in the equation when you now rewrite it, which does bring us to step 3. Rewrite, multiply everything back together, solve what you are left with, and then you are done with the problem. So over here on the left, we have the number 3 multiplying x plus 2 with the distributive property, and then the x minus 6, that's just going to stay the same. So 3 times x plus 2 is going to be 3x plus 6. And when that is set equal to x minus 6, and then you simply do some inverse operation skills, you're going to arrive at the answer of negative 6. You can see that x was subtracted from both sides, and that's what gives you the 2x. 6 was subtracted subtracted from both sides, and that's what gives you the negative 12. And then after dividing by 2, you get your final answer of negative 6. You're going to notice that that answer is not extraneous, which will hopefully make sense if I just jump back over to the previous slide, and you will notice the original function did not have a denominator that said x plus 6. If you were to substitute a negative 6 into either of these denominators, well, you would be okay. You're not going to get a 0 appearing in the denominator. So therefore, the answer of negative 6 is not going to be an extraneous solution. It is a good, valid answer. Now that we've done one practice problem, let's go ahead and jump into another one. I'll explain a lot of the same things, but we'll just go a little faster this time. So maybe take a moment, pause the video, and maybe see if you can even figure this one out without me walking you through it. So, all right, here we go. Once again, we're going to start with step 1, factoring your denominators to figure out what the common denominator is. So we're going to get an x plus 3 times x plus 5 from the x squared plus 8x plus 15 denominator that started off there. And now we can see that the unique denominators we have are just x plus 3 and x plus 5. So we're going to multiply both sides of this function by that common denominator, x plus 3 times x plus 5. All three parts of this rational equation are going to get that common denominator. Once you do that, cancel out the common factors that you have. So just to highlight this point, because once again, this is the main part of the video being exemplified here. In fact, I'll just back up that animation one more time. Notice how the common denominator is being multiplied to all three parts of this rational equation, and then the denominators that match the common denominator. So the x plus 3 over here on the left, those are going to cancel out because you have one copy of x plus 3 in both the numerator and the denominator. That only leaves you with the 7 and the x plus 5. Same thing right here in the middle with the x plus 5s. Those are going to cancel out, leaving just the x plus 3. And then all the way on the right where we originally got our common denominator from, the entire trinomial is going to cancel out because x squared plus 8x plus 15 factored into x plus 3 times x plus 5. So therefore, it matches the common denominator exactly, and it will cancel out in its entirety. And let's just go ahead and keep working on that. So the distributive property will now take over as we multiply everything back together to solve. So you're going to have 7 times x plus 5 for 7x plus 35. And then 3 times x plus 3. This is an important moment just to make sure your Algebra 1 skills are where they need to be. 3 times x plus 3 is going to give you 3x plus 9, but you're going to notice there is a minus sign in front of that expression, and that minus sign is the last thing that you would distribute, which is actually going to flip the signs of the positive 3x plus 9 to making it negative 3x minus 9. Very important step to perhaps back up and make sure you understand. Once again, let me just get all these green markings out of the way. When the x plus 5 cancels out, you are just left with the x plus 3. And then that x plus 3 is going to have the numerator of 3 distribute to it, giving you 3x plus 9. But because there is a minus sign in front of the entire middle part of this expression, that minus sign is going to flip the 3x plus 9 into negative 3x minus 9. Very important little step to notice there, just to keep track of your positives and your negatives. And then the rest of the function, the x plus 5, simply drops down because the entire denominator went ahead and canceled out. So now we're just going to do remaining solving skills, combining like terms, isolating x on one side, and through inverse operations, you get negative 7 as that solution. And that is, again, not extraneous because our denominators did not involve a positive 7 to basically have a denominator of 0 if you were to plug that back in. So negative 7 is a good answer. That is not valid. All right, here is a practice problem. In fact, it is one of 2 practice problems because that is how important this skill is. So please take a moment to pause and see if you can solve the easier of the 2 practice problems right now, and hit resume when you're ready. All right, here we go. So you would start by factoring that denominator, and you would get your common denominator of y minus 4 times y minus 1. You would then multiply both sides by that common denominator and cancel out a bunch of stuff. Multiplying things back together and solving by setting things equal to 0 will give you a single answer of negative 1 over 3, which is not extraneous, and it is a perfectly valid answer. So that was the easier of the 2 practice problems. Let's just go ahead and now check out the second one. So this one's going to be a little trickier because you're going to notice there is only numerators involving numbers, and it's not crystal clear what the common denominator is, but maybe you can use a little intuition and figure it out. So this will be the last practice problem we do, and go ahead and hit resume when you are ready. All right, and here we go. You would start by recognizing that the 2 has a denominator of 1, and that's not going to really affect your common denominator. So the only unique denominators you have in this problem are x plus 2 and x minus 1. When you multiply both sides by that common denominator and cancel things out, you will then use the distributive property, a little bit of factoring, and what makes this one a little extra tricky is that the quadratic formula is needed since your answer is not going to be a rational, friendly whole number. It's going to be an awkward square root, so you can just leave things in radical form with 5 plus or minus the square root of 73 over 4. Very good practice problem. If you can handle this, then you definitely understand the main idea of the lesson. Thank you for watching. Please drop a comment if you have any questions, and I will see you next time.